Hi everyone. Today we are going to be working on analytic geometry, calculating the distance between a line segment and a point. Go ahead, grab a piece of paper and a pencil, and let's get started. Number 1. Determine the shortest distance between y equals 3x plus 2 and the point A, 3, 1. So the first thing we need to do is calculate the slope of y equals 3x plus 2. So because we have the equation in y equals mx plus b, we can just look at the equation. The number that's in front of the x, that's our m value, or the slope. So I'm just going to write in here m is equal to 3. Next, we need to calculate the perpendicular slope. So remember, this is the negative reciprocal of the original slope. So we're going to take that slope, remember we can write it as 3 over 1, and we're going to invert or flip the fraction and then switch the sign. So the slope perpendicular is negative 1/3. Next, let's go ahead and graph y equals 3x plus 2, and then we're also going to plot the point 3, 1. So to graph the line y equals 3x plus 2, we're going to start at 2 on the y-axis. We're going to place our y-intercept. And then from this point, we're going to go up 3 to the right 1, up 3 to the right 1. If we run out of space, we could also go back to our original y-intercept, and we could go down 3 to the left 1. Go ahead and connect your dots with a ruler. Next, we're going to go ahead and plot the point 3, 1. So we want to find the shortest distance from the point 3, 1 to our line segment. So if we just draw random lines to this line segment, which one would be the shortest? The one that would be the shortest is the altitude. So it's going to make a 90-degree angle. So that's why we had to calculate the slope perpendicular. Part C says determine the equation of m perpendicular through the point 3, 1. Okay, so using y equals mx plus b, we're going to sub in the perpendicular slope. So y is equal to negative 1/3 x plus b. Next, we're going to sub in 3 for the x and 1 for the y. So 1 is equal to negative 1/3 times 3 plus b. So when I multiply negative 1/3 times 3, we get negative 3 over 3, which can be reduced to give us negative 1. So 1 is equal to negative 1 plus b. Rearranging the equation, 1 plus 1 equals b, so b equals 2. So our final equation is y equals negative 1/3 x plus 2. All right, the next part, we need to determine the point of intersection B between the original y equals 3x plus 2 and the new line that we just figured out in part C. Okay, so I'm going to call y equals 3x plus 2 equation number 1 and y equals negative 1/3 x plus 2 equation number 2. So essentially we're going to be solving a linear system. We want to see where those 2 points meet. So I'm going to sub 1 into 2. So 3x plus 2 is equal to negative 1/3 x plus 2. And we're going to rearrange. We're going to bring all of the x's to one side, all of the constants to the other side. So 3x is 3x plus 1/3 x is equal to 2 minus 2. So we need a common denominator. So I'm going to multiply the first fraction by 3. So we're going to get 9/3 x plus 1/3 x is equal to 0. So 10/3 x equals 0. If I divide 0 by 10/3, I'm going to get 0. So x equals 0. And we're halfway there. We still need to find the y part of the coordinate. So I'm going to sub x equals 0 back into either equation number 1 or number 2. I'm going to sub it into equation number 1 because there's no fraction to deal with. So 3 times 0 plus 2 is equal to y. So 3 times 0 is 0. 2 is equal to y. Or y is equal to 2 if you wrote it the other way. So therefore, 0, 2 is the point of intersection. So now that we have the point of intersection, we have 2 points on this line segment. So to find that distance, we're going to plug it into the distance formula. So I'm going to plug in my original point A and this new point of intersection that we just calculated, and that's going to give us the shortest distance. And when you see the word exact, that means we're going to leave our answer as a square root. Okay, so I just went ahead and subbed in my 2 points. So the 2 x values go in the first bracket and the 2 y values go in the next bracket. So 3 minus 0 is 3, 3 squared is 9, 1 minus 2 is -1, -1 squared is 1. So we have the square root of 9 plus 1. So the final shortest distance is the square root of 10. And if we don't have units, we physically write in the word units. So units. So that is our final answer for question number 1. So the shortest distance of the line segment is 10 units, square root of 10 units. Okay, let's go ahead and take a look at question number 2. Determine the shortest distance between y equals -1/2 x, subtract 5, and the point -2, 1. Okay, so same idea as before, we're going to calculate the slope. So we're given the line segment, y equals -1/2 x, subtract 5. So m is equal to -1/2. The slope perpendicular is equal to, remember we flipped the fraction, switched the sign, so 2/1 or 2, and we switched from a negative to a positive. So the slope perpendicular is equal to 2. Next, we're going to go ahead and graph the line. So I'm going to plot the y-intercept at -5 first. Then from there, to get more points, we use our slope. So -1, so down 1, and then to the right 2. So down 1, to the right 2. From there, down 1, to the right 2, and so on. You could also go back up to the original point and go up 1 to the left 2, and you're still in line with those other dots. And then go ahead and connect your points to make your line segment. Next, we're going to plot the point -2, 1. Okay, so again, in order to figure out the shortest distance, we're essentially calculating an altitude. So we're going to go ahead and determine the equation using our slope perpendicular and the point A, -2, 1. So y is equal to 2x plus b, and I'm going to sub -2 for the x. Y is going to equal 1. So 1 is equal to 2 times -2 plus b. So 1 equals -4 plus b. 1 plus 4 equals b. So b equals 5. And putting it all together, therefore, y is equal to 2x plus 5. Okay, so again, this is our equation number 2. So y equals 2x plus 5 is the equation number 2. Y equals -1/2 x minus 5 is equation number 1. I'm going to go ahead and determine the point of intersection by substituting 1 into 2. So 2x plus 5 is equal to negative 1/2 x, subtract 5. I'm going to bring all of the x's to the left, the constants to the right. So 2x plus 1/2 x is equal to negative 5 minus 5. Again, we need a common denominator, so I'm going to multiply the first fraction by 2. So 4/2 plus 1/2 equals, 4/2 x plus 1/2 x equals negative 10. Okay, so 5/2 x equals negative 10. 5/2 x equals negative 10. So we need to either multiply both sides by the flipped fraction, so 2/5, or we can multiply by 2 on both sides and then divide by 5, just an extra step, but either would work. So we get the 2's canceling out on the left, so 5x is equal to negative 20. Divide both sides. So we divide both sides by positive 5. So x is equal to negative 4. Then we're going to sub x equals negative 4 into equation number 2. So y is equal to 2 times negative 4 plus 5. Y is equal to negative 8 plus 5. So y is equal to negative 3. So therefore, negative 4, negative 3 is the point of intersection, the POI, or the solution. So now we have our 2 points that are on this new line segment, the shortest distance. So we're going to substitute that into the distance formula to find the exact distance. Remember, for the exact distance, we're going to leave our final answer as a square root. Okay, so we just went ahead and we subbed in our 2 points, the original point A and our new point. So remember, keep the x's in the first bracket, the y's in the second bracket. So we get the square root of, so negative 2 minus negative 4 is positive 2 squared plus 1 minus negative 3, so that's 4 squared. So equals 4 plus 16, so the square root of 20 units. So therefore, the square root of 20 units, so therefore the square root of 20 units is the shortest distance. Okay, that's it for today. Thank you for your attention. Bye-bye.